Hi, my name is Niraimathi, and for my chemistry CPT, I've chosen to do amoxicillin as my main compound. The chemical formula for amoxicillin is C16H19N3O5S. To begin, the functional groups within this compound include amide, thiols, alcohols, amines, ketones, phenols, and carboxylic acids. Moving on to indicate the type of hybridizations the central atoms undergo, the type of bonds created, the molecular structure, and the bond angles found within the molecules. The central atom for amoxicillin is nitrogen, which undergoes sp3 hybridization. This means that it is able to make 3 bonds and has 1 lone pair. As a result, it has a tetrahedral geometric shape, and more specifically a trigonal pyramidal shape, where each angle is 107 degrees. The other central atoms, such as carbon, goes through sp2 and sp3 hybridization. The sp2 atoms make 4 bonds with 1 double bond and 2 single bonds. As a result, they have a trigonal planar geometric shape, with each angle at 120 degrees. The sp3 atoms make 4 bonds as well, but with all single bonds. Therefore, they have a tetrahedral shape with each angle at 109.5 degrees. The sulfur atom goes through sp3 hybridization as well. It is able to make 2 bonds and has 2 lone pairs, and as a result it has a tetrahedral geometric shape, but more specifically a bent geometric shape, with each angle at 104.5 degrees. Amoxicillin has a total of 44 sigma bonds and 6 pi bonds. Amoxicillin is an antibiotic medication. It is used to treat various bacterial infections such as middle ear infections, strep throat, pneumonia, skin infections, UTIs. It is most often taken by mouth, usually as liquids for kids and as capsules for adults. It is one of the most commonly used antibiotics. It is an aminopenicillin that is created by adding an extra amino group to penicillin in order to battle antibiotic resistance. Its uses include covering a wide range of gram-positive bacteria as well as some gram-negative bacteria. It covers most Streptococcus species, and it is also effective against Listeria monocytogenes and Enterococcus species. It also covers Haemophilus influenza, some E. coli, Actinomyces species, Clostridium species, Salmonella species, Shigella species, and Carnibacteria species. Amoxicillin is in the class of beta-lactam antimicrobials, which means it contains a beta-lactam ring in its chemical structure. And as you can see here, this is the beta-lactam ring right there in its chemical structure. Some reactions amoxicillin is involved in includes when the beta-lactams act by binding to penicillin-binding proteins that restrain a process called transpeptidation, which is the cross-linking process in cell wall synthesis, leading to the activation of autolytic enzymes in the bacterial cell wall. This process leads to lysis of the cell wall, thus destroying the bacterial cell. This type of activity is referred to as bactericidal killing. Amoxicillin is similar to penicillin in its bactericidal action against susceptible bacteria during the stage of active multiplication. It acts through the inhibition of cell wall biosynthesis that leads to the death of bacteria. Thank you.